Hello everyone, this is Suprava. Welcome back to another session with me. In today's session, we will be dealing with hemophilia. So first, let us understand what we mean by the term hemophilia. So the term hemophilia comes from two Greek words, that is hemo and philia. Now hemo means blood, that we all know, and philia means love or affection towards blood. So that means hemophilia means love or affection towards blood. But instead of saying it as love or affection towards blood, the literal meaning of hemophilia is love to bleed, we can say. So that means the hemostasis process is impaired here. So one thing you have to remember in hemophilia, that the hemostasis process would be impaired here. So basically, hemophilia is a coagulation disorder or a bleeding disorder, we can say, in which we can, see that abnormal bleeding, or there will be exaggerated bleeding or poor clotting mechanism. So let us next move on to the definition of hemophilia. So next, let us move on to the definition of hemophilia. So hemophilia can be defined as a common hereditary coagulation disorder due to deficiency or reduced activity of specific clotting factor. So that means it is a hereditary disorder in which the clotting factors which are responsible for the blood clotting mechanism will be, in a reduced amount, or there would be deficiency of those clotting factors, and due to that there would be exaggerated bleeding, or there would be, poor blood clotting mechanism. Now we are also saying that there would be deficiency of specific coagulation factors, right? Now, we also know that there is coagulation cascade which is activated after any cut or damage, right? And there are in this coagulation cascade, there are several coagulation factors which play a major role in the whole blood clotting mechanism. So among them, the factor 8 and factor 9, these are the clotting factors which play a major role in the whole mechanism. Right. Now, in hemophilia, basically, as we are saying that there would be deficiency of specific clotting factors, that is, either there can be deficiency of factor 8 or there can be deficiency of factor 9. So here you have to remember certain things. The first thing is that it is a coagulation disorder where, the hemostasis process is impaired, right? And the second thing is that there would be deficiency of the clotting factors. Due to that, the hemostasis process is impaired. And the third thing is that it is a X-linked recessive disorder. Now, what do we mean by X-linked recessive disorder? So, X-linked recessive disorder means that this particular disorder can be passed down from parent to child through mutations in a gene on the X chromosome. So that means the X chromosome is carrying the faulty gene. And that's the reason, the male child will be affected with hemophilia and the female child will always be a carrier. So let us see why the male children are always the sufferer and the female children are the carrier. Now here we have a healthy father who is having XY chromosome, and we have a mother who is carrier of hemophilia. So we have denoted it as XHX. That means the X chromosome is here, it is carrying the faulty gene of hemophilia. And here we have the possible genotypes of their offsprings, right? So what we can see here is that there would be one healthy daughter and one healthy son. So there is 25% chance of, having a healthy daughter and 25% chance of having a healthy son. And then we can see that there are, one daughter and one son who is going to have this faulty gene, that is a XH, right? So for the daughter, it is XXH, right? So this daughter will be carrier, and then there is XHY, the son will be the sufferer. Now you might think that, why the daughter is the carrier, because the daughter is also having the same faulty gene, right? The daughter is also having XHX, right? Now here we are saying it is X-linked recessive disorder. That means both the X chromosome has to be, has to carry this faulty gene. So then only, that means it has to be XH, then only the daughter will be become the sufferer, or else the daughter will be a carrier. But in this case, as we have a healthy father who is having XY chromosome, where the X is not carrying any faulty gene, that's the reason, here we are having the daughter who is having XXH. So the daughter will be the carrier. And then we have 25% of chance of having a son who would be sufferer. So here the son is having XHY, right? So in case of male child, what happens? They get Y chromosome from the father and X chromosome from the mother. So in this case, there is no other X chromosome to dominate over it, right? So here the only X chromosome is present, and it is carrying the faulty gene. So that's the reason the son will be affected here. So this was about when there is a mother who is carrier and there is a healthy father. So next, let us see if the father is hemophilic. In that case, what will happen? So here we have a father who is hemophilic. So that's the reason we have marked it as XHY, and a healthy mother who is having XX chromosome, right? So in this case, what is going to happen? Now here you can see that both the daughters will be carrier, and the sons will not get affected with this. Now why this? Because again, in a male child, they receive only the Y chromosome from the father, and in this case the X chromosome is affected, right? So that is the male children would not get that affected chromosome. So that's the reason here the male children won't be the sufferer, but the female children, as they would only receive the X chromosome from the father, so that's the reason they will become the carrier. So we saw that the females are always the carrier and the males are the sufferer, right? Now the question is whether the females can become the sufferer or not. Now this is a very rare case, but for example, let us see if in case the father is hemophilic, that means XHY, and the mother is the carrier, that is XHX, right? Now this can happen in consanguineous marriage. So here what will be the possible genotypes of the offsprings? So here there is 25% chance of having a daughter who would be sufferer, that is XHXH. So as you can see that the father is having the father is hemophilic here, so he is having XHY chromosome, right? And the mother is also a carrier, that is XHX. Right. So as the female children would get X chromosome from the father and one more X chromosome from the mother, right? So in this case, the if the girl gets the the X chromosome which is carrying the faulty gene, that is XH, then in that case, there is a chance that the female child might become the sufferer. And then there is 25% chance of having a daughter who would be carrier, and then a hemophilic son and a healthy son. So I hope you understood the meaning of X-linked recessive disorder. Now let us move on to the pathophysiology a bit to understand how does the cut. So I hope you understood the meaning of X-linked recessive disorder. Now next let us move on to the pathophysiology to understand what actually happens in hemophilia. Right. Now, normally when there is a cut or there is a damage in the blood vessel, what happens? There would be an immediate vasoconstriction, right? So this vasoconstriction, why does it happen? Because there is increased blood flow, and that has to be stopped, right? So whenever there is a cut or a damage in the blood vessel, there would be an immediate vasoconstriction which would limit the amount of blood flow. Now, vasoconstriction is a primary response that happens just after the cut or damage to the blood vessel wall. and then some platelets would adhere to this damaged vessel wall, and then it would become activated. Now these activated platelets would again recruit some additional platelets to form a plug, because the increased bleeding which is happening, it has to stop, right? Now the formation of this platelet plug is called as primary hemostasis. So after this primary hemostasis, the coagulation cascade gets activated. Now in coagulation cascade, there is intrinsic pathway, there is extrinsic pathway. We would not go into that detail, but as we know that this coagulation cascade has a great degree of amplification, and it also takes a very few minutes to, from the injury to the clot formation, right? And then there are several steps in this coagulation cascade. The final step is activation of fibrinogen protein to fibrin, which deposits and polymerizes to form a mesh around the platelets. Now this is called as secondary hemostasis. So most of the time, in most cases of hemophilia, what happens, there is problem in this secondary hemostasis, because there is a deficiency of clotting factors. So either clotting factor 8 or clotting factor 9. So because of this, the secondary hemostasis process does not happen properly. So when the secondary hemostasis process is not proper, it is not that effective, or it is less effective, what would happen? That would allow more bleeding to occur, right? Yes, so in hemophilia, there is deficiency of clotting factor 8 and there is deficiency of clotting factor 9 sometimes, right? Based on the type of hemophilia. So because of that, what would happen? There would be weak platelet plug formation. Now, if the platelet plug is weak, then definitely that would allow more bleeding to occur, right? That won't stop the bleeding. And then there would be also incomplete or delayed fibrin clot, which would again allow the bleeding to continue. Next, let us move on to the classification. So in classification, majorly we have two types of hemophilia, that is hemophilia A and hemophilia B. So in hemophilia A, there is deficiency of factor 8, right? So when there is deficiency of factor 8, we term it as hemophilia A. Now hemophilia A is known as classic hemophilia. And then there is hemophilia B, which is also known as Christmas disease, and this one is due to the deficiency of factor 9. So as you can understand that there is deficiency of specific clotting factors in a